Welcome to Logistic Regression Made Easy. This short video course is to help us understand what this technique of logistic regression is all about. Logistic regression is the most commonly used statistical technique which is used by analytics professionals all over the world. Through logistic regression, we basically try to make an inference of the future event on the basis of the past data. So to get on to the training now, columns represent the customers. This data is all about which we have created for our own training only to predict the propensity of a customer to default on a loan which he has taken. Columns represents the variables, rows represent the individual customer record. For example, if a customer is a male, he will have value of 1 against it or a 0. If she is a female, then 1 or 0. If he has his own home, then 1 or 0. If he or she lives in an apartment, then 1 else 0. If he or she belongs to an ethnic group, for example Hindu, then 1 or 0. If he or she belongs to another ethnic group, say Muslim, then 1 or 0. And so on and so forth. Values which are under these labels are called as betas. Right now we have given all of them a value of 1. And here we have a value of intercept. Now if we can recall our elementary math, wherein we had learned that equation of a line is y is equal to mx plus c. N are the betas, which values are over here. X are the independent variables, that is these variables. And C is an intercept, which is this variable. In the row we have given each of them as a value of 1. And here y is the prediction for the default. Here right now we have given default as an indicator whether that particular customer had defaulted on a loan in past or not. And so what we do is we calculate a linear combination for them. The y as of now is this particular value which you get. So right now we have given them default value of 1. Values in the x, the independent variables values are given, and the intercept is given. Then we have calculated by summing them up through products their linear combination. Now from this linear combination we derive the probability. Probability is calculated by exp of the linear combination divided by 1 plus exp of linear combination. Now this function is called as link function. This function does nothing but crunches the value which lies in this range between 0 and 1. So when we apply this equation to these values, as you can see, values are between 0 and 1 respectively. So now we have the probability value and we have a default value. Next we calculate a squared error, which is nothing but default minus prediction of whole square. The reason we do whole square is that in some cases value will be negative. For example, herein default is 0. This is 0.9. If you subtract 0 minus 0.98, it will be a negative value. So squaring them gives all of them a positive value. The reason we go for a squared error is that eventually we sum them up and calculate a sum of squared error. Then our main objective is to minimize this sum of squared error by optimizing the betas, the values which are over here. So what we do, we go to a solver. This is a facility which is provided in LibreOffice as well as in Excel. However, in Excel, the solver is only of linear nature. So we would advise you to install a solver, an open source solver, which is a non-linear solver. So going ahead, we try to minimize the target value of x. Is minimized by changing source b2 to u2. That is the entire range of betas, and we have kept them value between 1 and minus. And we have selected an evolutionary solver, that is a non-linear solver. And we go ahead and solve this. The reason we require a non-linear solver over a linear solver, which is by default present in Excel, is because for calculation of sum of squared error, we have to square the value. Thereby, the relation is no more linear in nature, as a square of the error between default and probability comes into picture. So using a linear solver will not be good to reach our objective. So as you can see, the solver is minimizing the sum of squared value. Initially it was 471, now it has reached the value of 154. So as we can see, the solver has stagnated at this point. However, we would recommend that you finish that entire iteration, though it will take some time, but the result will be much better. However, for training purposes, we will be stopping here, as it is now more or less on our range. So well, it has crashed, but it will start once again. So yeah, this is the value of sum of squared error which we got. Now, basically the logistic regression is based on concept of maximum likelihood. Now, maximum likelihood is based on the concept of likelihood, and likelihood is based on the concept of odds. So, question often arises, why use odds when you have probability? The reason being is that odds is in itself combines the probability of event occurring as well as the event not occurring. Thereby, it's a comprehensive picture. For example, if probability of event occurring is 0.75 and event not occurring is 0.25, the odds of event to occur are 3 times more than event to not occur. So there is a considerable range, right? Like it is 0.5, here in the range will be 2. So differentiation is much more easy. And then likelihood is determined as P divided by 1 minus P whole to the power of y into 1 minus P. And then we calculate we take its log, and then we calculate the log likelihood. Now once the log likelihood is calculated, we sum all these values up to find out a sum of log likelihood. And since logistic regression is based on the concept of maximum likelihood, we go to our solver, select the maximum, and then try to optimize these beta. Here we can select a higher value and we can go ahead and solve this. Here I made a mistake of not selecting Z1. I expected B2 instead, so wrong figure came out. Now the solver starts. The solver often takes a longer time to come to a more optimized value. So it is often recommended that that you leave the system in the solver long, go and have some tea or something like that, and then come forward with the eye for a good result. However, in this case, since it's just for a training, so we will be keeping it short. So overall, logistic regression is initially based on optimizing the sum of squares, then minimizing the sum of squares by optimizing the beta, then maximizing the likelihood by again optimizing the beta values. Herein, as you can see, the iteration has begun. So when this green occupies the entire gamut, the operation is appeared to be. However, for comfort's sake, we will be stopping this operation when the current solution potentially stagnates. Since it has stagnated over here, we will stop this over here. So our model is ready. We have provided them the probabilities. Now the next step is to judge the accuracy of the model which we have built. So to do that, we will copy this entire sheet over here. And we will also copy the default. Then, as a next step, we'll sort this data in a descending order. Well, the main reason of sorting is to basically enable us information of what are called as deciles. Deciles is nothing but data split into 10 equivalent distributions. So, for example, this data set is 1000 rows long. So 100 rows form in one decile, the next 100 rows form in second decile, next in third, and so on and so forth. So we'll be taking this till the end. So now once we have broken them into deciles, what we'll do is we'll build a pivot table. So as you can see, the model which we have formed is on the first decile it is capturing 98 second 95. So the rank order is holding. When I say rank order should hold, I basically mean that in the first decile, the number of defaulters captured should be higher than what is captured in second, and subsequently higher than third, then fourth, and so on and so forth. However, in the seventh decile, it is slightly increasing. But as we have known that we have stopped our solvers prematurely, if we would have run those solvers, perhaps this problem would have not occurred. Even though we find that problems are occurring after we have run solvers to full extent, we might have to go for some variable transformations. Those transformations are currently beyond the scope of this work which we have done right now. But however, this is how your encoder looks like. You built a good, decent enough model, and this is what our equation looks like. So all we have to do is copy these values over here, and there you have it. This is how your complete model is. And if somebody wants to have the equation also, all you have to do is sum product and plus intercept. So there you have it. This is what your entire model equation is all about. I hope you have thoroughly enjoyed this small presentation, and you were able to get the concepts through to you. If you want to have this formula-fitted Excel sheet, please feel free to provide us with your contact information and we will email it to you. Plus, also, we have regularly the courses which are coming up, which will be of tremendous benefit to you, chiefly of understanding the concepts clearly and thoroughly. So, feel free to provide us with your contact information and we will keep you updated with whatever new is coming. Thank you very much.